Welcome to my channel. We are solving the quiz 1. Now we begin with the first question. It says, given that x plus 5 is a factor of f of x equal to x cubed plus 2x squared plus 5x plus 10, find the other real zeros. Now, for the first thing I'll say about this question was that the question x plus 5 is not a factor. How do we know this? When we do the factorization of f of x to be equal to x cubed plus 2x squared plus 5x plus 10. Now I have four components. I can group them into two. Then I have that I can factorize the highest power here, the lowest power here, which will be x squared. And then I have x plus 2. I'll do the same thing here, plus 5. And then I have x plus 2. Now, when we solve this one, we are going to combine them. We have x squared plus 5 and then x plus 2. So the factor here is supposed to be x plus 2, not x plus 5. So x plus 2, not x plus 5. Now, we equate it to 0. And when we equate it to 0, we have x plus 2 to be equal to 0, which is a factor already given to us. And then the next one is x squared plus 5 is equal to 0. Now, if I solve that, I have x squared to be equal to negative 5. I'll take the square root here, take the square root here. Then I have x to be equal to plus or minus I root 5. So that is what we have. And so we are having this, and this one is a complex root, which is not real. So in that case, our first question, the answer to that question is it has no other real root if the question is x plus 2 as a factor. All right, then we move on to the next part. It says, which of the following are the x-intercepts for the graph of the function h of x to be equal to 6x4 minus 7x cubed minus 37x squared plus 8x plus 12. So here we are being asked to find the x-intercept, and to find the x-intercept, we know that to find the intercept, it is y equal to 0, or we equate the function to 0. And so in that case, it will be 6x4 minus 7x cubed minus 37x squared plus 8x plus 12 is equal to 0. Now we do factorization. So what we can do is that we can use rational zeros to find that. So we find the factors of 12, the last number, and then the factors of the first number. That's the only thing we do. So factors of 12, that will give us, we have plus or minus 1, we have plus or minus 2, we have plus or minus 3, we have plus or minus 4, and then plus or minus 6, and then we have plus or minus 12 itself. So these are the factors of 12. Then we have the factors of 6. That will be, so factors of 6, that will be plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. So these are the two factors, that the factors of the first and then the last. Now, to find the possible rational zeros, possible rational zeros, rational zeros, what you have to do is that we will take the ratio between the last number and then the first number, and that will be, when I take the ratio, this one over this one, I'll get 1 plus or minus 1, and then this one over so the first one over the second one, that will have plus or minus half. I'll have plus or minus 1 over 3, and then I have plus or minus 1 out of 6. Then when I come again, I have plus or minus 2 over 1, that'll give me 2. So plus or minus 2. So plus or minus 2. So I don't want to bore you with the whole of these things. So when you go through all this process, you get the possible zeros. Then we test these values. We put the values in. So here, if I put the values in, the one that is giving me 0. So when I test, I had one of the roots to be equal to x minus 3 equal to 0. So this one, when I put 3 here, 3 here, 3 here, 3 here, 3 here, I'll get 0. And so in that case, 3 is a factor. And so I'll use the x minus 3 to divide whatever I have here. So I have x minus 3, x minus 3 dividing whatever we have there. That is 6x4 minus 7x cubed minus 37x squared plus 8x plus 12. Now when I divide, I have 6x cubed, then I have 6x4 minus 18x cubed. In that case, I will have 0. Then this one minus this one, that will give you positive 18. And then positive 18 plus positive 18 minus 7, that will give me 11. So I have 11x cubed minus 37x squared plus 8x plus 12. And then we now divide x squared, x going to divide 11x cubed. That will give us plus 11x plus 11x squared. And that will give us 11x squared minus 33. So we have 11x cubed, sorry, minus 33x squared. Now when I do the math, I'm going to have 0. Then here I have negative negative, that will give me positive 33. When I add it to negative 37, I have negative 4x squared plus 8x plus 12. Now if I divide again, I have negative 4x. Then when I have negative 4x squared plus 12x. And then when I do the math, I have 0. Then negative negative, that will give me positive. So I have positive 12, negative 12. Negative 12 plus 8, that will give me negative 4x plus 12. Then when I divide that by x, I have negative 4. In that case, when I do the division, I have negative 4x. I multiply negative 4 by 3, I have positive 12. Then I do the math, I have 0, 0. So in that case, I have this. Now, this one, we can enter this one into the calculator to find the other factors. So you just do this, and then you write your value down. That is x minus 3, where now x is equal to 3. And then now input whatever you get here into your calculator. And then when you input that one, you're going to have x minus 3. You have x plus 2. You also have 3x minus 2. And then you also have 2x plus 1. So these are the roots. So if you are going to write the intercept out, it should have been 3 0, and then 2 negative 2 0, and then we'll have positive 2 out of 3 0, and then we'll have negative 1 over 2 comma 0. This is what we are supposed to have, but we don't have that option here. So what we did was that we just made it as the x-intercepts should belong to a set, and the set is x-intercept should belong to a set, and the set is 3, negative 2, 2 over 3, and then negative 1 over 2. All right, so that was question 2. Question 3, they say we should use what we have here, so we can rewrite this one as a to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it says less than 10, so 10 is not part. Then with the b is giving us 3,6. Now the c says that the solution of the equation here, so we solve this one, and when we solve this one too, we'll have 3,6. Now question 3 says we should find a cross b intersection b cross c. So a cross b, what would we have? We are going to have 1, 3, we have 1, 6, we have 2, 3, and we have 2, 6, then we have 3, 3, then we have 3, 6, we have 4, 3, 3, then we have 4, 6, then we have 5, 3, then we have 5, 6, then we have 6, 3, we have 6, 6. All right, so if you continue to do it, we'll do it up to 9, 3, and then 9, 6. So that is a cross b. Then we have b cross c. In that case, we will have 3, 6, comma 3, then comma we have 3, 3, 6, then we have 6, 3, and then we also have 6, 6. Now when we take the intersection, what is here and is also here, then we'll have this, that will be 3, 3, 3, 6, we'll have 6, 3, and then what? 6, 6. All right, so that is all about that one. And so the option was not there, so it was a bonus, but this is the correct answer. Now question 4 too, similar to what we did. When we have b cross a, that is the components of b are crossing the components of a. So that means that b comes first and then a comes. So we have 3, 1. We have 3, 1. We have, and we have 6, 1. So if you also go through all the process, you're also going to have something like 3, 3, 3, 6, 6, 3, 6, 6 as the intersection of this one. So that one too takes the same element as we did for this one. You get it? So that one also has the same answer. So this one too will be 3, 3, then we have 3, 6, we have 6, 3, and then we have what? 6, 6. That will be the answer for this one. All right, question 5. It says that we should solve for t in this equation. Now, this question 2 had a problem. If we were to solve this question, we should have grouped like terms and then expand this one. We have negative t squared minus t plus 0.1 minus 0.01. That will give us 0. Now, if I evaluate this one, I have negative t squared minus t. Then when I subtract, I have negative 0. So plus 0.09 to be equal to 0. Now, when we are evaluating this, we get a radical, but the option is not there. And so this one had no option. So when we get to this point, and then the options are not there, you just have to go forward like that. All right. Then question 6. Question 6 was also a set problem. where we're given P intersection Q union P intersection Q. Now, what we do first is that we first take out the bracket. So we can take out the bracket where we have P prime intersection Q union P intersection Q. In that case, how do we take out the bracket? We multiply through by the union. And when we multiply through, we are going to have P prime intersection Q. Then this one will give us union P. Then this one and this one, when they meet, then union is the boss. So we have union Q. Now we rearrange whatever we have here. Then when we are rearranging, we have P prime union P, right? And then we have intersection Q union Q. Now we can solve that. Now P prime union P means that we are taking P and then its union, its complement, adding them together will give us the universal set, which is U intersection Q union Q will still give us what? Q. Now if you find the intersection between the union and then Q, we will have what? Q. And so our answer was supposed to be A, that is what? Q. Now question 7. Question 7 says we should solve this one. Now we are given x plus 3 greater than 4. Now for absolute values, you can either go through by using the properties, or you just square both sides. So we just square both sides. When I square, I have x plus 3 all squared to be greater than 4. Now when I open this one up, I'm going to have x squared plus 6x plus 9. That should, we expand this one, we will have two numbers we multiply to get -7, and when we add, you will get 6. So we'll take 7 and -1. So 7 and then 7x and then -1 minus 7. That should be greater than 0. And then when I factor, I have x plus 7, and then I have x minus 1. In that case, this should be greater than 0. So we are going to test values which are appropriate for this one. So we use our number line. So if I use the number line, the values of x will be -7 and then 1. Now I take any value here and I put it in a function. So if I take -8 and put it here, I have -8 plus 7. That will give me -1. And then I'll put -8 here. -8 minus 1, that will give me -9. I already have -1 here, -9 here. When I multiply, I have 9. Then the question is 9 greater than 0? The answer is a big yes. So this place works. Then I come here, I test values within this one. So -7 and 1, I have 0. I put 0 here, I'll get 7. I'll put 0 here, I'll get -1. Now 7 times -1 will give me -7. The question is -7 greater than 0? The answer is obvious, it's a no. So this place doesn't work. Then we come to the last part, this part. Then we test, we put a value there. So let's say 2. 2 plus 7 is 9. Then 2 minus 1 is 1. So 9 times 1 will give me 9. Is 9 greater than 0? Yes, and that is obvious. So all the values of x here satisfy the equation. So all these values are less than this. We all agree with that. So all these values x are less than -7, or the values are greater than, all the values here, they are all like 2, 5, 10. They are all greater than 1. So x is also greater than 1. So which of them compares to the answer? A. And so that is all about that one. Then question 8 takes the same format, where we have what we have here. We have to solve. Now to solve this one, we also use the same thing. We square both sides. So I have absolute of 3x minus 1 greater than or equal to 2x plus 3. So if I square here, I have 3x minus 1 squared greater than or equal to 2x plus 3 squared. Now I open this one up, I have and 3 times 3, that will give me 9x squared. And 3 times that 3 times 1, that will give me 3 3x times, that will give me plus, that should be greater than 6, that will 12x half 9, so plus 9. So we have a group across, then have x 4x, then minus 6x x, then we have plus 9 minus plus 1 minus 9, sorry, it should be greater than or equal to 0. Now if I do the math here, I have 5x squared minus 18x, and then when I do the math here, I'll get minus 8 greater than or equal to 0. Now two numbers we multiply to get negative 8, but when we add them, we are getting negative 18. So here we can also apply the quadratic formula, or we just go into our calculator and we just enter the value. So if you enter into the calculator, you are going to have 4 and 2 over 5. So we have x minus 4, and then we also have 5x minus plus 2 should be greater than or equal to 0. So we use the number line here to find the values of x that will be appropriate for the sign we have. So we have negative 2 over 5, that is somewhere 0.4, negative 0.4, sorry, and then we have 4. So we test values. So if I 0.4, I can type 0.5, put 0.5 here. So 0.5, negative 0.5 minus 4, that will give me negative 4.5. And then negative 4.5, if I put negative 0.5, I'll get negative 2 point, negative 2.5 plus 2. That'll give me negative 0.5. When I multiply negative, I'll get positive. And so automatically this side will be greater than 0. And so this side holds. Then I'll put 0. If I put 0 here, 0 here, I have negative 4, and then multiplying positive 2. Now when I multiply the two of them, I'm going to get a negative number, which will not make this inequality true. So this part will not work. Then I'll take 5, I'll put 5 here. 5 minus 4 is 1. Then 5 here, I'll get 25 plus 2, that'll give me 27. When I multiply, I'll still get positive, and which this side is true. Now all these numbers here are less than negative 2 over 5. So we say x is less than negative 2 on 5, and all the values here are greater than negative 2 and 5, negative 4. So we have x is greater than 4. But when we put 4 into, it's satisfying the equality. So it is greater than or equal to, and then this one too is less than or equal to. Sorry. All right. So take notes. Now, Question 9 says solve this inequality. Solve this inequality. So we still have a rational an absolute function. Now, as soon as we see this, where we have absolute of 4 minus x to be less than a negative number, we don't need to go further because the absolute of a number can never be less than 0. And so since you are saying it's less than negative 3, then in this set, x has no values. And so we are saying that it is a null set. So that is all about that one. Then we go to question 10. It says which of the following fractions is an irrational number? Now we know that rational functions are functions that can be expressed as in the form a over b, where b is not equal to 0. Now a and b belong to the set of integers. A and b belongs to the set of integers. So now if we compare what we have here, we have 101 over 15. Is this one an integer? Yes. Is this one an integer? Yes. So this one is a rational number. Is this one an integer? Yes. This one is an integer. Yes. And so this one too is a rational number. But when we come here, is this one an integer? Yes. Is this one an integer? The answer is no, right? And so in that case, this is an irrational number. And so the irrational number now here is C, which is this. So we are using the definition to choose our answer. Now question 11, it says we should find the range of this function. So what we do is that for the range, we are making x the subject. So let f of x be equal to y, and then we will have y to be equal to absolute of x plus 5. What we can do here is that we will make x the subject. And so how do we make x the subject? We can have absolute of x to be equal to y minus 5. But we know that absolute of x is always greater than 0. So this one should be greater than what? 0. Greater than or equal to 0, sorry. So greater than or equal to 0. So if I'm going to solve this one, I have y minus 5 to be greater than or equal to 0. And if I'm going to solve that, I have y to be greater than or equal to 5. And in that case, which one of them matches my answer perfectly? And then the answer is what? Is B. So I choose my B nicely. Then we come to question 12, which says that which of the following is not a subset of Q? Now, if you look at the diagram or the set of real numbers, we have real numbers sitting at the top, which is represented by that. And then we have branches. It branches into two. We have rational, which is Q, and then irrational, which is Q prime. Now, under rational, we have what we call integers. So we have integers, which we represent by a z. Now, under integers, we can have whole numbers. And then under whole numbers, we can have natural numbers. So these are all under rational numbers. But as we can see, we can't really see that real numbers are sitting on top, right? But natural numbers, they are here, whole numbers are here, integers are also here. And so in that case, real numbers is above Q. And so here the answer is A. Now we go to question 13. It says you find the domain of the function. And when we say a domain is a set of numbers that makes a function defined. Now for this particular function to be defined, anything under that root, the root sign, should be greater than 0. Should be greater than or equal to 0. In that case, what we are saying is that 4 minus x squared should be greater than or equal to 0. Now we solve for x. So let's solve for x. When I'm solving for x, I have negative x squared to be greater than or equal to negative 4. Divide through by negative 1. Negative 1. Now, since I divided through by negative 1, the sign changes. Then I have x squared to be less than or equal to 4. Now I'll take the roots. I have x to be less than or equal to plus or minus 4, minus 2, sorry. Now when I want to write it out, there are two numbers here, so it's either x is less than or equal to 2, or greater than or equal to negative 2. And so this is the answer, and so the answer is D. Then we go to question 14. Question 14, all the following are rational numbers except. Now here, most people might say, okay, since we are saying that rational numbers, pi from our basic school days is equal to 22/7. But that is not the case. So someone might choose to say, okay, then 7 times 22/7 will give me 22. So in that case, this is a rational number. Now, when we go through, this one is a reoccurring decimal. It's a rational number. When we come here, root of 25 is 5, which 5 is a rational number. And then 25/7 is a rational number, as we can see, integer over an integer. But this particular pi is an irrational number, and it has attached to a number here. So this pi here, because of it being an irrational number, this disqualifies the whole thing to become what? A rational number. And so the answer is what? B. Now question 15 says, given any two real numbers, a and b, one and only one of the following statement is true: a is greater than b, a is less than b, or a is equal to b. So which of the rules satisfy that? And that will be the what? The trichotomy law. For the cancellation law, we have the left cancellation and right cancellation, where we say a b equal to ac. Then it implies that b is equal to what? C. That is the cancellation law. When we do left cancellation, we can also write it as BA is equal to CA. Then we do the right cancellation. We have B to be equal to C. It doesn't change. The zero product is that when we multiply AB, then we have BA is equal to 0. Then it means that either A is equal to 0 or b is equal to 0. That is the zero product. And then the zero multiplication is when we have a times 0 is the same as 0 times a, and that will give us what? 0. So these are the rules, and these are their interpretation. Now, which of the following holds for a set of all real numbers? Now, this question had an omission, and the omission was, which of the following does not hold, does not what? Hold. So in that case, addition properties hold for all real numbers. Yes, it holds. Equality property also holds for all real numbers. Now, transitivity properties also holds. But for translative property, we don't even have that there. And so in that case, the answer should have been C. But we gave it out as that. Alright. Now we go to question 17. So we should find the quadratic equation whose roots are this. Now, for all quadratic equations, we are saying that it is giving us a bracket, so ax squared plus sum of roots, so plus the sum of roots, so root of x plus the product. Sorry, so here is supposed to be minus, so let me do that. Here is supposed to be minus, so minus the sum of roots plus the product. Now they've given us roots. They gave us x1 to be equal to 1 minus root of 5, and then x2 to be equal to 1 plus root of 5. So we find the sum. So the sum will have 1 minus, so we have x1 plus x2, and that will be equal to 1 minus root of 5 plus 1 plus root of 5. When I add, this one will cancel that. I have 1 plus 1, that will give me 2. Alright. and then the product multiplying the two of them. So we have x1 x2 to be equal to 1 minus root of 5 times 1 plus root of 5. Now if I enter everything into my calculator, what am I supposed to get? I'm supposed to get 1 times 1, that will give me 1. Then 1 times root 5, that will give me plus root 5. And then that will give me minus root 5. And then I have this 1 times that one, that will give me minus 5. Then when I simplify, this one cancel that. Then I have 1 minus 5, that will give me negative 4. So if I'm going to put it in my equation, I have x squared minus 2x minus 4 to be equal to 0. And so the corresponding answer is A. And that is what we have. Now we move on to question 18. Find the Cartesian product of P cross T if P is that and then T is that. So we are just going through the process where we are saying that P, so the first element should come from P and the second element should come from T. So when we are going to cross, we have P cross T to be equal to, so we have 3 and 3. So from the first to this one, and then we have 3 and 5. So we have 3 and 5. Then we have 5 and 3, and then we have 5 and 5. Then we have 7 and 3, and then we have what? 7 and 5. So this is what we have. When we compare this one to this one, we are having the answer to be C. All right. Then question 19 says we should find the vertex of the parabola here. So we have to find the vertex. We can go through by two ways. We can use the formula or we use the method of completion of squares. So if I want to use the formula, it is the vertex is given us. So we have the x part, the x component to be equal to minus b over 2a, and then the y component is given us 4ac minus b squared all over 4a. So from our equation, a is equal to negative 3. B, so you should rearrange it. If you will get confused, that is negative 3x squared plus 6x plus 17. So if you rearrange it like this, you'll be able to see that this is my A, this is my B, and this is my C. Now A is negative 3, B is equal to 6, and C is equal to 17. Now I substitute that into this. I have my x to be equal to negative 6 over 2 bracket negative 3, and that will give me negative 6 out of negative 6, and that will be 1. Then the same thing for my y component. I'll have 4 bracket negative 3. My c is 17 minus 6 squared all over 4a, which is the a is negative 3. Now when I evaluate everything and I put it in the calculator, I have 20. So I have 1 and 20. So the vertex is 1 comma 20. So the correct answer was A. Then we go to question 20. Question 20 says we should find the axis of symmetry, and the axis of symmetry is giving us x equal to negative b over 2a. So negative b over 2a. From our question, what is our b? Is 12, and then what is our a? Is negative 18. Right. So we substitute it inside the formula, and then we have negative b, so negative 12 over 2 bracket negative 18. If I do the math, I have negative 12 over negative 36, and then I'll have 1 out of 3 as my answer. And so the answer is C. Please do well to take your time and go through the steps so that you'll be more conversant with how to solve this problem. And then after learning this thing, you can look into the description. Tap on the link and then go and solve the questions and see whether you truly understood whatever we've done here. Thank you, and please subscribe. Bye bye.